next thing we are going to learn is inequality with number line. Inequality with number line. So before we delve into number line, okay, let's understand what we refer to as number line. What are number line? Number line is a range of numbers that contains two kinds of integers. We have the positive integers and the negative integers. So for instance, let us assume I have a line, and on that line I assume that my center should be 0. So at the right hand side of the line, I'm going to have my positive integers. So in this case, I'm going to have 1, 2, 3, 4, 5, and so forth. While on the left hand side of the number line, I'm going to have my negative integers. And on this case, this is where I'm going to have my -1, then -2, then -3, then -4, and so forth. So this is a typical example of what we call a number line. But there are some rules we have in number line that we need to know. Okay, rules of number line. What are the rules we have in number line? I'm going to give an examples on those rules and how we can apply them, because most of the time you'll be asked to represent the answer you have on a number line. So the first rule is, let's assume we have a is less than x and less than b. Now what does it actually mean? It means that my x is a range of numbers, but the x is greater than your a, but that same x is less than b. So for me to represent it on a number line, we usually have it this way. Here is my x. So my x relating to b, here is my b and here is my a. Because my x is less than b, now I can see that the b is at the right hand side, and my x is greater than a, now I can see that the a is at the right hand side. Sorry, left hand side. Y is at the right hand side. So what does it mean? It means my b is greater than x and my a is less than x. So if I want to write it on a number line, it's very, very important, in the sense that I'm going to have it this way. Yes, circled, then connected to this side, also circled. So what does it mean? It means that my x in this case is greater than a, and my x in this case is less to my b. Less to my b. So this is how we represent that on number line. But before then, you also need to know that sometimes they use integers for you to judge them. Whenever we have something in this form and is not shaded, and likewise is not shaded, we usually refer to it as open. So for me to represent that, I can say my x is open to a, and that same x is open to b. What does open actually mean? The open there, it means I'm using a curve parenthesis, or let me use the word bracket. So for this case, because my x is less than a and less than b, I have two opens. That means the both of them are open. So let's consider another rule, which is our rule 2. Okay, in our rule 2, let's consider another case in which we have our a less than x, then less than equals to b. In this same case, if I want to represent this on a number line, how do I do this? Very simple. Same thing, draw your number line. Here is your x. So you know that your x is greater than a, but it is less than or equals to b. So in this case, my b will be at the side, my a will be at the side. So the question is, what will happen in the inequalities? So if I want to draw for a, I'm going to have it in this way. Then at this side, connecting to b, then I have that. But for this case, because here is just ordinary less than, I only have it as just circle without shading it. But in this case, it is less than or equals to. So that means I need to shade it. Can you see that? So that's the meaning. Anytime you have your less than or equals to in a number line, or greater than or equals to in a number line, we usually shade it. But if you just ordinary your less than or greater than, you don't shade. So this is how you represent them. So if I want to write them in form of numbers, I can say my x is open to A but close to B. As you can see that the parentheses or the brackets are not the same. I have here to be open and I have here to be close. Going on to the next rule, which is our rule 3. In our rule 3, let's assume we have the other way around, A less than or equals to X and your X is less than B. How do we represent it on number line? The same thing, I'm going to have your X at the middle, then we have here as our A because it's less than and equals to. The other one we have here as our B. So for me to represent it on number line, I'm going to have the circle, but I'm going to shade it. Then connecting that to your B, I'm going to have the circle, but I'm not going to shade. Why? Because here is just ordinary, greater than or less than. Why? Here is just ordinary or less than and equals to. So anytime we have less than and equals to, we need to shade. But when it comes to greater than or just ordinary less than, you don't shade. That's just the meaning. So if I want to write that on numbers, I'm going to say that my X is equals to the square bracket represent close at A, comma, open at B. This is very important. Okay, move to our next rule, which is our rule 4. In our rule 4, let's assume we have that our X is less than or equals to, our A rather, is less than or equals to X and less than or equals to B. And I need to represent it on a number line. For me to represent it on a number line, I have here to be X. Then you know here will be A and here will be B. So in this case, I will have it that the circle is open, circle here is open, but this time they are both shaded. Why? Because both of them are the less than equals to sign. For us to represent it on a number line or in number, say x is equals to close at A, likewise the x is close at B. These are the rules of number line you should know because we are going to apply them to our questions. Okay, move to our very first question, which is our grade 1. In our grade 1, we are given a question that says solve the equation and show the solution in number line. We have to solve the equation and show that equation on a number line. So we have it as minus 3 less than 5 minus 3x less than or equals to 11. Now if you look at this case, we are given two different kind of inequalities. So how do we solve it? The way you solve it is you are going to separate the inequalities relating to the middle term. How do we do that? First thing is here we have minus 3 less than 5 minus 3x, or the same thing that 5 minus 3x less than or equals to 11. So in this case, I'm going to find a way to find the value of my x, likewise the other side to find the value of my x. So doing this, I'm going to have it as collecting like times here, I'm having minus 3 minus 5 less than or equals less than 3x, sorry about that, or for the other side I have it as minus 3x less than or equals to 11 minus 5. When I try to bring the minus 5 to the other side, but for this case, when I try to bring the 5 to the other side, it's going to turn to positive to negative, right from here turn to positive. So in this case, what do we have here? We have minus 3 minus 5, that's a minus 8 less than or equals to 3x, and the other side we have it as minus 3x less than or equals to 11 minus 5, that's just 6. So in this case, I need to divide both sides by minus 3. Minus 3. So here we cancel out minus 3, then your minus cancel out minus. Now recall something. There's something very important we need to know. Anytime you are dividing with a negative sign of the variable of x, again, anytime you are dividing with the negative sign of the variable of x, you will make sure that the inequality sign go upside down or opposite to one another. So it means I'm going to have here x greater than, sorry, not greater than, I'm going to have here, we have here 8 over 3. Now before it was less than, now it will be something like this, greater than x. As you can see, the sign or the inequalities was less than. So because I divide by minus 3, it turns to greater than. This is how you deal with signs of x if it is negative. But when we come to this case, the same is applicable, dividing both sides by minus 3, minus 3. Cancel, cancel. So because I'm dividing that with a negative sign, yes, minus 3 here is 1, then here you have it as minus 2. So I'm going to have that x, instead of me having less than equals to, I'm going to have greater than equals to minus 2. So these are the value of x. So representing this on normal line or writing this, I'm going to have it at first I have that k over 3 greater than x, or and I have that the same x greater than or equals to minus 2. So let's try to represent this by combining them together. For me to combine them, I'm going to have minus 2 less than or equals to x, then less than 8 over 3. I've combined the two answers I have. So in this case, I would advise you to convert this to what? A mixed fraction. It actually help you where you can place them on a number line. So I'm going to have minus 2 less than or equals to x less than 3 in 8 is just 2 whole number 2 over 3. So it means it is found in the range of 2 and 3. So if I want to represent it on number line, I'm going to have my x in the middle. As we all know that here should be what? Minus 2. And here should just your 2 whole number 2 over 3. It's not almost you have the whole numbers written on them. What they need is to represent them properly on a number line. So in this case, I'm going to have here as, then to be shaded connecting to this. So this side will be shaded. Why is it shaded? Because we are having less than or equals to, but this side is not shaded. Why is it not shaded? Because we're just having ordinary less than. So this is how you represent it on number line.